That's going to be a weird number. That happens. Weird numbers. Did I show you guys the 3D visualizer stuff yesterday?
Or is it because it's a 90? Is it because it's a 93? So how do you get the height as it's 90-30, 60-30? I put the float things in math. Oh wait, if you found I said hypotenuse. I said the tree. I thought it was half and then square root and then plus how did that it's 1 over height, right? I don't know if I did it. Don't know if that's right. But we're 12.
Alright, let's keep.
You're just be like this. I don't know how it is.
Sean was there. Thank you. Alright, so yay for experience substituting in the 5th grade in land of Cornell. Cherry pie is delicious. Apple pies are chew, and you have to say chew like that so that you know it's an exponent. Oddly, in this unit, one of the you guys again, you're doing the calculus right. It's the arithmetic that you're doing wrong. Area of a triangle, half base times height. Y'all are gonna forget the half. And you get area and circumference mixed up. Sean said it right. So, Nick, what is the area of a circle with this radius?
Pi x squared over 4.
Yep. Okay. I don't think I asked this in this class yesterday, but I asked the other 2 classes to find the area of an equilateral triangle. Side length was x, not 4x, but it took a long time for one person in both classes to finally get it right. You guys are the ones that had geometry online. Already starting to show. No offense or anything, just. What's the height of that? 2 root 3x is what Ari says. Why is he? It's not the x underneath it. Why? I heard you guys say something.
Pythagoras would not work.
Pythagorean theorem. This is a 30, 60, 90 triangle. It's why the template that we had you remember for pre-cal works. And we get this by doing Pythagorean theorem and then we just memorize it. Okay, so area of the triangle is 1/2 the base. This is another mistake. You guys will cut things up and you'll do part of the triangle. And then you'll use the base of the little piece rather than the whole piece. The base is 4x. The height, already says, is 2 root 3x. So what do we get overall? Yeah. 4 root 3x squared. What's that equation? Jasper? Equation of a circle with the origin as its center, radius 1. Cool. And they're not going to do this to you, but what if the center was 2, -3, and the radius was 4? Anybody remember this? Again, check it. Ask Kalia.
X minus 2 squared plus y plus 3 squared equals 60.
Okay. Those of you going to multivariable, need to remember to be able to shift the center. She did the opposite signs of this to move it to the center, and it's radius squared. Conic sections, just a little. Those of you headed to physics. Yeah. All right, so today we're adding another dimension. We did area, now we're gonna do volume. Yay. And they have horrible names. We're finding volumes of known cross sections. The wording of these are just terrible. So to find the volume of something, we're gonna do little slices and find the area of every slice. So here's a little setup, like if you take the area of this circle and the smaller circle and the smaller circle and the smaller circle, we can end up finding the volume of a cone. Grady, does it matter if I do things, like if I take the slices up and rearrange them, is the volume gonna change? No. So even though it no longer looks like a cone, this thing will find me the volume of a cone, and it's gonna drive some of you crazy because I'm gonna leave it like this. You guys hate that. But like, I made all the little stacks of the circles be different, but they really did make a cone at one point. I rearranged them, now they're just weird. So the point of this is to show you, you're like, hey, we find the area of a square, a whole bunch of little squares that actually have no depth. This one's depth is delta y. A ream of paper is 500 flat, skinny little sheets of paper. It takes up a lot of space. So it has this infinitesimally small thickness. We could have also done the slices this way. So the way we're going to find volume is find the area of a slice, multiply it by its thickness, and then integrate it over the whole section. All right. So this is why the warm-up was what it was, because I need you to remember how to find areas. So circles, triangles, squares are largely what we need to do. What's the question? People are writing stuff, I'm not sure what you're all writing. But does this make sense? Might be better if I show you. Yesterday, sorry, can I cover this up a second? Let's see, Preston, square, equilateral, triangle, semicircle, pick one. Okay. So there's my one slice. And if I want to know the volume of the shape that's created by making a whole bunch of semicircles where the diameter goes from the red curve to the blue curve. It's going to look kind of like that. And the skinnier I make the slices, the more smooth, like it's like 3D printing, right? Do any of you do 3D printing? And the longer time that you have it set, like the skinnier the slice, the more smooth your thing is that you're 3D printing. So with it smooth, it's going to look like that. And if it's more spaced out, it's going to look kind of like that. And just because it's fun, this one looks like a fish with a mohawk. Right? Fish with a mohawk. Okay, so the point of it is to say we need to find an equation to find the area of each little triangle And if we add all of those triangles up, we'll get the volume. And we're gonna get the area of the triangle in as functions. Like the base of that triangle is red minus blue. And that changes as we move along the axis. So that dx is the integration variable that will give us volume. All right, what does that mean? So here's the game plan for each thing. We're going to sketch the picture, and I recommend that you take the cross section out. Like, is it a triangle? Is it a semicircle? So you can identify, do I know the diameter? Do I know the radius? Do I know the height? What do I need to figure this out? So pulling the picture out, or writing the picture, then you can see more clearly what you need to find the area of. And then integrate that thing. Integrating area gives you volume. You added a new dimension. And again, the links to all of these GeoGebra visualizers, which you might need for some of the homework, are all on the Chapter 7 module in Canvas. Some of them you can change the formulas, some of them you can change the shapes better. Just there's some out there. Okay. Can I turn the page? Yeah. All right. Some of you will say, but even though geometry was online, I know how to find the volume of this. Yeah, okay. We're gonna just try the question anyway. So we have a pyramid that is 3 meters high and has congruent triangular sides and a square base. That square base is 3 by 3 by 3 by 3. And every cross section parallel to the base is a square. Find the volume of the pyramid. So what's the area of the cross section shape? The cross section shape is a square, and the volume, or the area, is going to be x by x. So the first thing is try and draw the solid. I am more or less not so good at drawing the picture. But this cross section, pulling it out, it's a square. Okay, Nick said area of a square, x by x. So the process of finding volume, that cross section, that area of the square, and then we're going to give it a thickness. And that thickness that we're going along the x-axis is dx. The bounds, they told me in the problem, 0 to 3. Raise the power, divide by the new power, and plug in. What are the units? It's meters cubed. Because it's now volume. It was meters by meters, and then there was a skinny little thickness of meters. All right, let's try the weird ones. So now we have like or a rounded fish, donut. See if you guys can draw the picture of the cross section, label some dimensions, and this is the warning I was trying to, I can never repeat the words that they say for this. A solid is made so that its shape, so that its base is the shape of the region between the x-axis and one arch of the curve y equals 2 sine x. Each cross section cut perpendicular to the x-axis, to the x-axis. So is that a dy or a dx slice? Dx. So all the little slices are dx. So I need the equation in terms of x. And then the diameter runs from the x-axis to the curve. Horrible wording. So Brooke, what's the area for a circle again?
Pi r squared.
So Alex, what is this, Alex? What is the area of a semicircle?
Pi squared of 2.
Massimo, what's the equation for my radius? Or don't I know that?
So you half of 2 sine x, which is sine x.
Okay, so the diameter went from the x-axis to the curve. So the radius is half that. Okay. So Josh, what's the area of the area equation of a single semicircle?
You plug it for radius.
So it's gonna be pi,
It'd be pi, 2 sine x over 2 sine.
2 over 2 reduces, so that. Okay, so Kai, again, paper?
Choose again.
Isn't it half of that?
Yeah.
It's only since one half.
So half the circle, this was pi r squared, half of that again, okay?
Oh, yeah.
Because if we were doing whole circles, it would go around the back, and it could be blunt, but I only wanted half. So Kai, what do I set up to find volume for this problem?
Integrate from 0 to pi.
Do you guys think you can do the pre-cal identity trick? Because I cannot integrate cosine squared, or sorry, sine squared. But I can integrate cosine 2x. There were 3 different identities. What is the one that I should use for this?
2 sine squared x.
Cosine 2x isn't, that's not the right one. It comes with
Cosine squared x minus sine squared x.
cosine squared x minus sine squared x, but I don't want both of those because now I can't integrate cosine squared or sine squared. But I can get rid of cosine squared by swapping it out and get this. Solving for sine squared. So integrate that. Getting it?
Square root.
Pi squared over 4. It's a weird number, but there it is. John, yeah? Questions? Ready for the next temperature? Well, shoot. They didn't even give us no picture, no equation, which is why I asked one of the questions on the warm-up. What is the equation for this? X squared plus y squared equals 1? Okay, because the nature of this is a circle, it's got a symmetry on the x and the y axis. You could do it incorrectly and you'll still get the right answer because of all this symmetry. But, drawing that circle. Triangles, the small leg lies on the plane and it's perpendicular to the y-axis. Okay. So the small leg and perpendicular to the y-axis. 30, 60, 90 triangle. So this guy's going to be longer. Small leg, perpendicular to the y-axis. Do we agree with the picture at all? And I could put the right angle on the right side. It doesn't matter. It just says the small leg's here, it's a right triangle. But for whatever reason, I prefer the back to be over there. Okay. Pulling just one of these out, again, I don't have any equations. What are the thicknesses of these gonna be? DYs or DXs? DYs. Thickness is DY. It's getting confusing. So when it's DYs, I need an equation for the right side, which is going to be x equals, and I need an equation for the left side, which is x equals. How do I get that?
One minus y squared root of 1 minus y squared.
Okay, that I put the square root in, I need to do a plus and a minus. What is the equation for this side over here where x is positive? The positive part. This side back here is the negative part. Or you could think about it and be like, well, it's symmetric. So what is the length of that short leg?
That square.
It's right side minus left side. So that, gross. And it told me these were 30, 60, 90 triangles with the short one there. What is the other dimension that I still need in my triangle? Grady, what do you think? I need the height. What is the height if this is the across from 30 side?
Inverse tangent.
No inverse tangent. We're not gonna get that crazy. I mean, they're mean, but they're not that mean. Does that help at all?
2, 3, 1, 2.
So whatever the across from 30 is times root 3, yes. Gross. So Alex, Alex, what is the area formula for my triangle that looks like that?
1/2 of parentheses, root 1 minus y squared, squared, no, not squared, times, root 3, and the same, 1 minus y squared.
Okay. The base was 2 times that square root thing, and Grady said the height is this thing. Just it sounded like you were doing a couple of steps together. So half base times height, these two multiplied together, I get 4 root 3 and square root of times square root of, isn't that just stuff inside? Did I forget a half this time? So I think that's your area formula. Base times height, right? You said the half, so the area of the triangle is half base times height. So the half base and height, the constants became this, and the square roots times square roots.
If the triangles were facing like if you like shifted them like 90 degrees, would it then be dx or no? Like let's say
Okay,
like,
that's still the same equation.
no, that's dy, but if you switch it like
Yeah, so like I said, if you made them this way, perpendicular to the x, the slices would be dx, and because this is a circle, you could have done it wrong, and you'll still get the same answer because it's a circle.
okay.
So integrate that. Oh, what are the bounds? Uh-huh.
Can you do 0 to 1 and then multiply that again?
I would prefer that. So he says integrate from 0 to 1 and double it, or negative to 1 to 1, and then you're going to be dealing with subtracting negatives and possibly doing them wrong. don't remember what's under the box. Tried to draw it with like not crappy handwriting. But 8 root 3 over 3. Yeah. Okay. So, can you try this? It has been a warm up in the past. That's a Z, not a 2. Anyone get an answer? I know they're ugly. There's fractions. There's radicals. There's stuff. Were you able to draw the picture? So mean with the algebra 2, asking you to do a conic section, a parabola that's not a function. It goes sideways and it goes to the negative direction. It's because we needed it to get cut off by the x-axis. Is the thickness dx or dy? Dy, okay. Can we do a symmetry thing like Martin did on the last one and go from 0 to 2 and double it? Yeah. So this was someone's actual warm-up exit card, whatever. And they get the gross number of 256 over 15 root 3. What do you think? Questions? It's tedious more than it's hard, but there's lots of places to make simple mistakes, which is why I didn't announce it in this class, but there's a quiz Wednesday next week on 7.1 to 7.3. So something on there will be find the volume of this weird shape. Questions about this one? Still looking? Sophie, it looks like you have a question, but you're not asking. No. There's the first two parts of the homework. So actually, question 1 is 4 parts, all using the same equation. So they're asking you to figure out with cross sections, 4 different styles from the same equation, oriented the same direction. So start.